We're going to talk about congruence of integers. And first of all, we're going to look at a definition of something called congruence modulo n. Congruence modulo n. What does that mean? Well, first of all, you need to know that n is a positive integer. N is also greater than 1. And then you have x and you have y. Those are also integers. They don't have to be positive, but they are integers. And we say that x is congruent to y modulo n if and only if x minus y is equal to a multiple of n, which means that it's equal to n times k for some k in the set of integers. Okay, so we write that as this: x is congruent to y modulo n. So x is congruent to y modulo n if and only if x minus y is equal to a multiple of n. So for example, I can say 3 is congruent to 7 modulo 2, and that's because I know that 3 minus 7, which is equal to -4, is a multiple of 2. Right? We know that that's equal to 2 times -2. Another example is 5 is congruent to -13 modulo 9. And that's because 5 minus a -13 equals 18, which is a multiple of 9. Okay? So this is what it means for two numbers to be congruent to each other modulo n. N is called the modulus. Okay? Another way to look at congruent integers modulo n would be when you divide n into either one of the numbers, you'll get the same remainder. For example, in the first example, if I were to divide 2 into 3, my remainder would be 1. 2 goes into 3 one time, so 2 goes into 3 one time, and the remainder is 1. If I were to divide 2 into 7, goes in 3 times, and again the remainder is 1. So whenever you're dividing, two numbers are congruent also if you take the modulus and divide it into the numbers, and you end up with the same remainder. So I know that 3 is congruent to 7 modulo 2. Let's see if that works for the second example. It's a little more difficult to see because 9 doesn't go into 5, but if you can use the division algorithm to write 5 is equal to 9 times 0 plus 5. And we know with the division algorithm, this number here is always the remainder. And it's another challenge to divide 9 into a -13. Well, let's do it. Let's remember when we did it in class before. 13 is equal to 9 times 1 plus 4. But we want a -13. Right? So if we multiply both sides by -1, we get this. But remember, our remainder has to be negative, so we need to add and then subtract 9. And so I end up with -13 is equal to 9 times -1, but then I'm going to use this. That's plus a negative 9. So here I have a negative 9 here that I can put with this negative 9, which gives me a negative 18, which is a negative 2 times 9, and this gives me plus 5. So now I can see what the remainder is when I divide 9 into negative 13. And again, I know that negative 13 and 5 are congruent modulo 9 because you have the same remainder when you divide both numbers by 9. Congruence modulo n is an equivalence relation. Remember when we talked about equivalence relations, you had to have 3 properties. The first one was you had to show reflexivity. The next one you had to show was symmetry. And then you had to show transitivity. For reflexivity, I had to show that x is related to x. For x to be related to x, that means that x is congruent to y modulo n. I'm sorry, x is congruent not to y. It should be x is congruent to x modulo n. Well, let's see if that's true. What does that mean? That means that x minus x is equal to n times k. Well, that is true because x minus x is equal to 0. 0 is equal to n times 0. So reflexivity holds. Congruence modulo n is reflexive. Now we have to show that congruence modulo n is symmetric. So what we're going to have to do is we're going to have to assume that x is related to y. Well, x is related to y means that x minus y is equal to, or let me say this, that means that x is congruent to y modulo n. And that means that x minus y is equal to n times k for some k in the set of integers. Well, suppose I were to take the negative of both sides, or multiply both sides by negative 1. Well, this is just y minus x, which is equal to n times negative k. We have y minus x is a multiple of n, so that means that y is congruent to x modulo n. Starting off, assuming that x is related to y, we find that y is related to x, right? And then lastly, for transitivity, we have to assume 2 things. We're going to assume that x is related to y and y is related to z. Well, what does that mean in terms of congruence modulo n? That means that x is congruent to y modulo n, and it means that y is congruent to z modulo n. Well, that means that x minus y is equal to n times k for some k as an integer. And then it also means that y minus z is equal to n times, I have to use another integer, we'll call it maybe p, for some p in the set of integers. And doing a little bit of substitution here, I'm trying to see what x and z, the relationship between those two are. Well, if I solve this for z, I know that z is equal to y minus n times p. And if I solve the first one for x, I know that x is equal to nk plus y. Okay, so I know that x minus z is equal to nk plus y minus y minus np. Well, that means that x minus z is equal to, my y's are going to cancel, that np becomes a positive np. I end up with n times k plus p. So x minus z is a multiple of n, which means that x is congruent to z modulo n. So we've just shown that assuming that x is related to y and y is related to z, we see now that x is also related to z.